All right, find the log base 2 of 32. So we're thinking, basically, if we set this equal to x, we're rewriting it exponentially. So we've got 2 to the x equals 32, and x will equal 5. Given that log base 2 of that can be written as that, find the value of p and q. So when we're dividing, we can separate logs by subtracting individual logs, and the exponents come out. And we know that this is 5 because 2 to the 5th power is 32. And we know 2 to the 3rd power is 8. So P is 5 and Q is negative 3. All right, we've got this. Let log be that, express that. Okay, so we can distribute that exponent. So we're going to have log base 10, P squared over Q squared R6. And then we can separate it because we're dividing P squared minus log Q squared plus log R6. Okay, because we are dividing by both Q squared and R6. So you could have also written it like this, which I'm going to do because I'm distributing anyways. And our exponents fall back. And we know log p is x, so this is 2x. Q is y, and this is minus 6z. All right, we have that stuff, write that stuff. So we're going to have log x squared plus log, I'm going to put y to the 1/2, minus log z cubed. All the exponents fall back. And log x is a, log y is b, and log z is c. Same thing here. Log base 10x minus log y squared, also minus log z to the 1/2, because we're also dividing by z. So this is p, and then the 2 will fall back, and log y is q, and the 1/2 will fall back, and log z is r. Okay, so this one we can separate. It's just natural log, that's base e. So we've got natural log a cubed plus natural log b. The 3 falls back. Natural log a is p, and natural log b is q. For b, we're dividing, so we're going to have log natural log a to the 1/2 because of square root minus natural log b. The 1/2 falls back, and natural log a is p, and natural log b is q. All right, express the following in terms of p and or q. Okay, so we can rewrite log base a of 10 as 5 times 2, then separate it. Log base a of 5 plus log base a of 2, and that's going to be p plus q. For b, this in 5 or 2 is going to be 2 cubed. The 3 falls back, and log base a of 2 is q. C, that's going to be 5 over 2, which we can separate by subtracting because we're dividing. So we're going to have p minus q. All right, this one for ai, we can multiply 5 times 3 and then separate by addition, and that's going to be q plus p. For double I, we're going to have 5 squared. The 2 falls back, and q. And find d, so if we rewrite that exponentially, we're going to have d to the 1/2 is 6, And we just square both sides to get d is 36. For a here, we have that the 2 falls back, log base 5 of x, which is 2y. For b, you can look at it a couple of ways, but we're going to have x to the negative 1, which the negative 1 falls back, and that's negative y. And c, where you can do change of base. So if we have, because we have base 5, so of the big thing, the x, over log base 5 of the small thing, the base, 25. And we know log base 5 of x is y, and this one is 2, because we know 5 to the 2 is 25. So for a, we can do change of base, because we want base a. So we have log of the big over log of the small, and that's going to be y over x. And for b, we do have log base a, and we can do 5 times 2 squared. And that separates into addition, and the 2 falls back. So we're going to have y plus 2x. All right, so we can separate natural log 10 into 2 times 5 and separate with addition. So this is going to be x plus y. For b, this is going to be 2 squared times 5. Then separate by addition, and that exponent 2 falls back, and natural log 5. So that's going to be 2x plus y. For c, we can change base. So we're going to have log base e, natural log of 5, the big thing, over natural log of the small thing. So that's going to be y over x. Okay, finally some equations. All right, we can just rewrite this exponentially. We've got 3 to the 2 is 2x plus 1. So 9 minus 1 is 8. X is 4. For b, we've got e to the 2, because this is base e, equals 2x plus 1. So we're going to have e to the 2 minus 1 over 2 equals x. Okay, so you could take the log of both sides, but you can just also write a exponentially, because it's log base 5 of 625 equals the exponent x plus 1. And I only did that because they want it to be written the exact value. So this is that. And for b, we have that we can write this exponentially. A squared is 3x plus 5. And we're solving for x, so we're going to have a squared minus 5 over 3 is x. Just looking in the answers, 5 to the 4th is 625. So this is going to be 4 minus 1, which is 3. So this one we'll write exponentially. 2 to the 1 is x squared minus 4x plus 6. It's quadratic, so we need to get it equal to 0. So this is plus 4 when we subtract the 2. This factors to x minus 2 squared, so x is 2. This one, again, rewriting exponentially, 16 to the 1/2 is the cubed root of 100 minus x squared. So this is 4. 16 to the 1/2, that's square root of 16, and this equals that. Now I'm going to cube both sides, so we'll be left with 100 minus x squared on this side, and 4 cubed is 64. Now if I subtract 100, that's minus 36 equals negative x squared, divide by negative 1, so x is going to be plus or minus 6. Now, if we put those back into the equation, it doesn't matter because x is squared. So both of those are a solution. Okay, so this one we have to join some logs together. So we're going to have log base 2 of x times x minus 2 equals 3. They give us a domain, so we have 2 to the third is x squared minus 2x. When we distribute the x and rewrite it exponentially, and then this is quadratic, so we need to get it equal to 0, so subtract 8. And we have to factor, so we know it's x minus 4, x plus 2. So x is either equal to 4 or x is equal to negative 2. They already told us x greater than 2, so that's not it, only 4. And you could have substituted these back into the equation. Remember, what you're taking the log of, that has to be positive. That's why, this first one, x is greater than 0. The second one, x minus 2 is greater than 0. So if you have the first solution is x greater than 0, the second is x greater than 2, their intersection is here, so that's why it's that one. For 36, given that x equals log base 3 of a, express a in terms of x. So join together. We have x over x minus 5 because you are dividing. Now we have log base 3 of this equals log base 3 of this, so those things have to be equal. X over x minus 5 equals a, and we need to express a in terms of x. That's that. And then b, hence or otherwise solve the equation that equals to 1. So you have that this is 1. So log base 3 of x over x minus 5 equals 1. So if we write this exponentially, 3 to the 1 equals x over x minus 5. And cross multiplying, we're going to have 3x minus 15 equals x. And then when we subtract 3x, we get negative 2x. So x is going to be 15 over 2. For this one, we have to do a couple of things. I'm first going to get rid of the 2. So multiply everything by 2. So we're going to have 2 log base 3 of x plus 2 equals 2 plus log base 3 of x. Now this exponent 2, and we need to write this 2. So we want log base 3 of what? We want to write 2 as a log base 3. So it's got to be 9 because 3 to the second power is 9. And then we have still this. Okay, so this side's fine. It's all together. But this one, we now joining those together, it's going to be 9x. So just like the last one, we've got this log base 3 of that equals log base 3 of that. Those two things have to be equal. So if we expand the x plus 2 squared, that's going to be x squared plus 4x plus 4 equals 9x. Subtracting 9x, we're going to have minus 5x plus 4 is 0. And then if we factor, we have this. So either x is 4 or x is 1, and both of those work. Okay, so this one we need to get all of these things together on the left side, but also they're just numbers. So log base 9 of 81 is 2 because 9 squared is 81. This is negative 1 because 9 to the negative 1 is 1 over 9. And 9 to the 1/2 is 3. Okay, so this is 1. This is 3 over 2 on the left. And if we do 9 to the 3 over 2 equals x. So that's going to be 27 because it's going to be, the 2 comes out, so that's the square root of 9, and then 3 outside, so that's going to be 3 cubed 27. All right, 39 solve this equation. Okay, so we have 10x plus 20. I'm going to put the 2 up, and we're subtracting, so that's division. Okay, equals 1. Now, we can write this exponentially. The base is 10, so 10 to this one is equal to 10x plus 20 over x squared. Cross multiplying and getting equal to 0. And also I'm dividing by 10. And we will factor this to x minus 2, x plus 1. X plus 1 equals 0, so we have x is 2 or x is negative 1, and straight away we can't have negative 1 because of that. But 2 is fine. Okay, 40, we need to get those together. So it's going to be log base 2 4x, that 2 pops up, so times x squared equals 5. And then we're going to have 2 to the 5th equals 4x cubed. So that's going to be 32 over 4 is x cubed, so 8. So x is 2. Okay, this one is fine on the left. But we need to write 2 as a log base 2, and that's going to be of 4. And this 2 will pop up. And we need to get that together. 5x squared minus x minus 2. And those together is log base 2 of 4x squared. And then we have these things, and the logs are equal. Get it equal to 0, so x squared minus x minus 2 equals 0. It factors to x minus 2, x plus 1. So x is 2 or x is negative 1. Can't be negative 1, but 2 is fine. 42, we can get the left side together. That's going to be x times x minus 3. And this is going to be log base 5 of 2, and that exponent comes up. So we're going to have x squared minus 3x equals 4. So this equals this. And quadratic, so equal to 0. So x minus 4, x plus 1. So x is 4 or x is negative 1. And it can't be negative 1 because of this and this. So it's just x equals 4. All right, for this one, log base 27 of x, the left side's fine, but we need to write 1 as log base 27. So that's going to be 27. And minus log 27 x minus 0.4. Honestly, you could probably just put this straight into the graphing calculator and end solve this part, and it would do it. But I'm going to get it combined. So we're going to have log base 27 of x. And getting this together, we're going to have 27 divided by, x minus 0.4. So x is going to equal 27 over x minus 0.4. It might give you 2 answers, but we'll probably reject one. So we've got x squared minus 0.4x, and then getting the 27 over to equal 0. So when I do it in end solve, I get x is 5.4 when I do this in unsolved. But when I put this part in the polynomial tools to find the roots, I get negative 5 and 5.4, but we wouldn't accept negative 5 anyways, but just be careful. So for this one, we'll go ahead and put the exponent up. Oops. So it's going to be log base 3 of x minus 3 squared. And then we have plus log 1/3 x plus 1 equals 2. So we can get this 1/3 into base 3. So we can do log base 3 of x plus 1 over log base 3 of 1/3. And log base 3 of 1/3, 3 to the negative 1. So we will have, this is negative 1. So we're going to minus log base 3 of x plus 1. And getting those together, we are dividing. So it's going to be x minus 3 squared over x plus 1 equals 2. And then we're going to have 3 squared equals, when we write it exponentially, I'll expand that out. That's x squared minus 6x plus 9 over x plus 1. So we're going to have 9x plus 9 when we cross multiply equals this. Getting it equal to 0. That's x squared minus 15x. So if we factor out an x, we're going to have x minus 15. So x is 0 or x is 15. And we cannot have x equal 0 because of this. That would leave a negative. And 0, well, never mind, it's not the case, but 15.